What's up? Last lesson of the week. Heck yeah, so awesome. I just wanted to talk to you guys about a couple things. One, like I totally understand that like learning online is super hard. I took an online class in college and it sucked. It was like really difficult, and it's really difficult for me too. Like I really wish I could be in the classroom and like really help you guys. I'm working really hard, and I just want you to know that like I feel you, and please, like, I really appreciate those people that are reaching out to me and telling me that they're having a tough time, because I want to be able to do anything that I can to make sure that it can be less sucky. Okay. As far as like the amount of work that I assigned at the beginning of the week, it really was just, it was totally not to overwhelm you. I wasn't trying to just like unload on you guys. It was just that I felt like logarithms is kind of like the one thing that you really need to learn in integrated 3. And it so sucks that we had to like do it online. And so I felt like a lot of people cheated on the last quiz. And I just really wanted to make sure you guys were solid on logarithms and that you truly understood it. I'm totally accommodating you guys. I know that you have like a lot other classes and probably lots of other responsibilities at home. So if you guys need to turn things in late, that's no big deal. Just try to like keep as best as you can, keep up with the work. It's good to like set schedules for yourself, um, and all that. And also, like, totally reach out to me if you're having any problems, like keeping up with the work, or if you don't really understand what's going on. I really appreciate everybody who's been coming to my office hours and letting me know, like, hey, Miss Elward, like, I'm feeling overwhelmed, or I don't feel like I understand this. I love those emails. I like to know what's going on with you because I care about you, and so just keep me updated with you. Plus, it's just nice to hear from you. Okay, so today we're going over factoring. It's like all review stuff, so you already know, but it's just really just kind of a refresher because you need it for the next chapter. So the topics that we're going to cover today are like basically what is a monomial, like what does it mean to factor, the greatest common factor, and just kind of like factoring as far as the reverse distributive property, trinomials of the form x squared, like with when a is 1, and then just kind of when a is not 1. Okay, so let's start with the monomial. Okay, so what is a monomial? So a monomial is a number variable or product of 2 or more with whole number exponents. Really, it's a term. Some examples are like 12, because 12 is a number, so that's a monomial. Y is a variable. So that's a monomial. And then negative 5x squared. Okay, so that's a product or 2 or more numbers or variables with whole number exponents. So whole number exponents means the whole number exponents on the variable. So x squared has the exponent 2, that's a whole number, and y has the exponent 1, and that's a whole number. And then like c over 3, although it may not look like it's product, it is because it's 1/3 in c. So c over 3 is also monomial. So let's kind of figure out if you understand. So what is it, a monomial or not? So first question is 2/3 x a monomial? So yes, it is. Right? It's product of a number and a variable. 2/3 and x. Is x plus 3 a monomial? No, it's not. It's a binomial, so it's x plus 3. It has to be a product. It can't be a sum or difference. Right? And then 3 root x, is that a monomial? No, it's not, because x has technically an exponent of 1/2. Right? So that's not a whole number. X squared plus 3x plus 6, is that a monomial? No, it's a trinomial. It has 3 terms. Negative 4, is that a monomial? Yes, it is, because it's a number. And 7x squared y cubed, is that a monomial? Yes, it is. Okay, so factoring. What is factoring? So factoring, it undoes or reverses distribution. An example of factored form and expanded is 2 times the quantity of x plus 5 is factored form, and that's the same as 2x plus 10, and that's just expanded form. So how to factor, it's just basically finding the greatest common factor, also known as the greatest common divisor, and pull it out of each term. And so let's get into that. So how do you find the greatest common factor? So finding the GCF. So to find the greatest common factor, use prime factorization, and then your GCF is the product of the common prime factors. So let's do an example. So find the GCF of the monomials listed below. So here are 3 monomials, negative 30x cubed y, 24x to the 4th, and 48x squared y cubed. So let's prime factor each of these. So let's start with negative 30x cubed y. So negative 30x cubed y. So negative 30 prime factors is negative 1 times 2 times 3 times 5. So that's negative 30. And then x cubed is x times x times x. And then y is just y. And then 24x squared, right, that prime factor is 2 times 2 times 3. And then the x to the 4th is x times x times x times x, right, 4 x's. And then 48x squared y cubed, y to the 5th, sorry, is 48 prime factors to 2 times 2 times 2 times 2 times 3, and x squared is x times x, and y to the 5th is y times y times y times y times y. Okay, so once you prime factor, basically your greatest common factor is the product of the common prime factors. So which things do they have in common? So just break it down in numbers, for example. So what numbers do they have in common? Well, they have 2 in common. Right, so they all have at least 1, 2. They also have at least 1, 3. And then the variables, like how the most what they have in common, right, are they all have at least 2 x's, right? And then the y's, well, only negative 30x cubed y and 48x squared y to the 5th have y's, but 24x to the 4th does not have a y, so they do not have any y's in common. So your GCF is just those 4 things. 2 times 3 times x, which is 6x squared. Okay, so then once you find your GCF, then you can use the reverse distributive property. So here we're going to be first practice with reverse distributive property. So it says factor the polynomial below. So here are some 4 examples. So let's start with the first one. First, you need to find the GCF. So the GCF, the greatest common factor of all 3 of those terms in number 1, is negative 6x squared. And then really you just do the reverse distributive property. Really you kind of pull out that and you figure out negative 6x squared times what is going to give me negative 30x cubed y. So negative 6 times what is negative 30? 5. And x squared times what is x cubed? X. And then you still need your y. So negative x squared times 5xy will give you the first term. Right? And then negative squared times what gives you the second term. So negative 6 times what gives you 24? Negative 4. And then you're still missing x squared. And then negative 6x squared times what gives you 48x squared y cubed, or y to the 5th. Geez, why do I keep doing that? Then it's negative 8 y to the 5th. Okay, let's do problem number 2. What's the GCF for problem number 2? 9p. So 9p goes into all of them. So 9p times what gives you 18p cubed? You need a 2 to get to 18 and 2 more p's to get to 18p cubed, so 2p squared. And then 9p to negative 63p squared, you need a negative 7 and another p. And then 9p times what gives you negative 9p? Just negative 1. Okay, number 3, what is the greatest common factor? 36r s squared, so then really that's just the first term, so that's times 1, and then 36r s squared to get to negative 108r squared s cubed, you need a 3 to get negative 3 to get negative 108, and then you need an additional r and an additional s to get r squared r cubed. Okay, last one, what goes into all of those? 6 And then that's just times n squared, negative 5n, and 7. Okay, let's go on to factoring trinomials with a coefficient of 1. Okay, so we're going to start with trinomials of the form with the coefficient of a. We're going to start with these examples. So these are diamond problems. You first need to, I'm going to show you the shortcut, and then we're going to do the more complicated ones later. So all you really need is a diamond. I apologize. Your answer is going to have two parentheses, right? You're going to have two binomials. You want to put the last term in the top of your diamond and the middle term in the bottom. You just do the numbers. 28 and negative 12. And then you think to yourself, two numbers that multiply to negative 28 and add up to negative 12. So 4 and 2. And then those just determine what goes in your parentheses for your final answer. So it's x 14. So you can see the negative 14 comes from the negative 14 in your diamond. And then x plus 2, positive 2 comes the 2 in your diamond. Okay, so then the next one, you set it up. So in your parentheses, and then you put the last number in the top and the middle number in the bottom, 48 and negative 2, and then two numbers that multiply to negative 48 and add up to negative 2 are negative and 6, and then those determine what goes in your parentheses. So minus 8 goes in your parentheses, that comes from the negative 8, and 6 goes in your other parentheses, that comes from the positive 6. So the trinomials of the form ax squared plus bx plus c, so when they have numbers in front of the x squared term, right, those look a little more complicated. So you can't do the quick way, but they still involve the diamonds. So your answers are going to have two binomials. To set up, you have a diamond and an area model. So what you want to do is you put the first and the last terms in your area model in the bottom left corner and the top right corner, as so. And then you multiply them together, right? And then you get 60n squared. And then you put the middle term of your original problem, 19n, at the bottom of your diamond. And then the diamond's the same. So two things that multiply to 60n squared and add up to 19n are 15n and 4n. And then you put those in your area model. And then you basically do the reverse distributive property of your area model. So if you look on the left column, right, 5n squared and 15n, what can you pull out of 5n squared and 15n? You can pull out 5n, right? And then the bottom row, right, 5n squared and 4n, what can you pull out of there? Just an n, right? And then that should work. N times 5n should equal 5n squared. And then you continue, like 5n times what is 15n? Positive 3. And then n times what is 4n? Positive 4. And then the positive 3 and positive 4 should multiply to 12, right, if you did it correctly. And then those dimensions go in your parentheses. So plus 3 and 5n plus 4 go into your, and that's your final answer. Okay, so let's do this one, next one. Okay, so nk squared and 21 is huge. So it's really important to make sure that, like, before you multiply them and do this whole area model diamond thing, that make sure they're, like, use your reverse distributive property if possible. Is there anything that you can take out originally? So yes, 3 goes into all of those numbers. So then you know your answer is finally going to be 3 and then 2 parentheses. And so then you do the reverse distributive property on the original problem. I apologize. So 3 times what is 9k squared? 3k squared. And 3 times what is 66k? 22k. And 3 times what is 21? 7. And then you do the area model and diamond on what's left in the parentheses. So the 3k squared is the first term and the last term, right? They go there. You multiply them, and then you go 21k squared, and then you put your middle term at the bottom diamond. And then what multiplies to 21k squared and adds up to 22k? 21K and K. Put those in your area model. And then now you have to find the dimensions of your area model. So then, again, you do like the reverse distributed property. So if you look in your left column, right, 21K and 3K squared, they have K in common. And then on your bottom row, they both have K in common. And then 3K times what is 21K? Positive 7. K times what is K? 1. And then your dimensions go in your parentheses. So K plus 7 and K plus 1. Okay, last one. So since they're all negative, you want to pull out a negative to begin with, right? And then you get 6, 8, and then you know your answer is going to have negative parentheses, and then inside you're going to get 6a squared positive 25a and positive 25. And then you do your diamond area model after that. So then you put the first and last terms in your area model, multiply them and put them in your diamond, and then put the middle term in your diamond. And then two numbers that multiply to 150a squared and add up to 25a are 15a and 10a. Then put those in your area model. Then do reverse distributive property. So the bottom row, 6a squared and 10a, what do those have in common? 2a, 6a squared and 15a, what do those have in common? 3a. Then 3a times what is 15a? Positive 5. 2a times what is equal to 10a? Positive 5. And then write positive 5 times positive 5 is 25. And those dimensions go in your final answer. So it's negative 2a plus 5 times 3a plus 5. And that's it. So hopefully that was enough review for you able to complete the homework handout. Again, please reach out to me if you're like feeling like overwhelmed or you just want to say hi and like thank you for my videos. That's cool too. Okay, bye. Miss you.